Toulouse, then, south of France. I'm belonging to the CNRS, and my lab is also belonging to the University of Toulouse. And some people know this picture. And this is the observatory which is linked to my lab in the French Pyrenees. And then quite high altitude, and just less than 3,000 meters. And that's a beautiful observatory. We observe still there, here, 2 meter telescope, in a spectropolarimetry. To reconstruct the magnetic field at the surface of stars. And we get very good results with this telescope. And that's the question. Maybe one time we should organize something, some fancy code meeting. It will be maybe difficult to organize a meeting in the observatory because for security reasons. It's not, normally we just can stay one night with 20 people, not the week. But maybe if we organize a principal meeting in France, maybe we can have a trip there for one day to visit the observatory.
Is that then settled? So next year we have a I think it's settled.
Maybe we can discuss about that. Maybe.
You tempted us last year also.
Yes, that's true.
So there's nothing to discuss, I think, just to agree on.
Yeah.
Unless someone is jumping and saying, me. Also.
Yeah. That's Anders was me. That's okay.
That's what I will ask.
Yeah. So, outline of my thoughts, or introduction. I will briefly speak about what is Python and why using Python. I will give you some practical information concerning the installation of Python. So, Python and pencil code. I will discuss what we do actually with Python and some conclusions. So, what's Python first? It's quite new language because it has been created in '91 by this guy, Dutch guy, in Amsterdam. And now this guy is called in the Python community benevolent dictator for life. And in fact, actually he's working for Google since 2005. Because I learned that most of Google stuff is written in Python. And so this guy came, and now the contract is simple. Half of his time is for Python, and half of the time is for Google. I think that's a very good contract. And why the name Python? Because this guy likes so much Monty Python, Flying Circus. You know, maybe Monty Python, Flying Circus. Monty Python, it's on BBC, and it was terrible, really terrible. This one is maybe one of the most famous sketches of Monty Python, Flying Circus. It was just before the journal was sequence of Monty Python. History actually works. But you can look on YouTube, there's some sketch like that I will show you. Okay, you can do it. So the first release was in '91 on alt.sources. That's the history. Original posting to alt.sources, 91. And in fact, what is not very good is that Python has funding from DARPA, a military department in the US. Guido made a funding proposal to DARPA the title was Computer Programming for Everybody in 1990, and he get a lot of money for that. And that's 4 sentences that I extracted from the DARPA funding proposal. So the first goal was an easy and intuitive language just as powerful as another computer, open source, understandable, and suitability for everyday tasks, allowing for short development times. And then you get a lot of money to do that. And now you see the year and the version number of Python. Actually, we are here, 2.5, and Python 3K is what is called 3K for 3.0 is plain at the beginning of 2009. And the main problem with this new version of Python is that there will have no backward compatibility with 2.5, 2.4, and so on. So they claim that if you want to code the new stuff within Python, you must use the very last version of Python, because next year only the backward compatibility will be just with the last version of Python, 2.5, 2 or 3, something like that, but not with 2.2 or 2.0 version of Python. So why Python? Of course, it's free. Ideal in France, for example, as I said to Toby, in my lab, if I want to buy IDEA, it costs around 1,000 euros for one workstation. So that's very, very expensive. So of course we all have crack of IDEA, but that's not the correct way to work.
This is something recorded, right?
I will repeat.
So Python is free. And so I think it's quite easy to use. Indeed, in 1 week you can write easily Python program. Another good point, it's object-oriented. And indeed, in Python you have classes. And classes are very useful in programming. It's highly modular. It's a good point, but also it can be sometimes a bad point, because compared to IDEA, in IDEA you buy the software and you have everything in the software. In Python you have modules for plotting, for statistics, for a lot of things. And then if you want to use that module, you have to load that module. In IDEA, when you launch IDEA, you get everything. In Python, it's not so simple. You have to import some modules. It's much more rapid than IDEA. Much more rapid than reading, for example.
This I can't believe. I mean, maybe some stuff is, but when you work with large arrays of data, I've never seen something that is significantly faster than IDL, and is not just compiled C or Fortran. IDL is optimized in that respect, so I'd like to hear more about that claim.
But Python is not compiled, or is it interactive? Is Python interactive, or is it interpreted?
It's compiled in C.
Well, IDL is compiled in C in the same
Yes.
sense.
Or is it interactive when you do
To my experience on 3D arrays, for example, large simulation of around 20 gigabytes of data, I want to read each data separately. It was much more faster with Python than with IDEA. But maybe I have a whole version of IDEA, now I have a 5.8, something like that.
And operations on that array?
No, any operation, just reading bar file with a read bar, IDEA subroutine that we have, and it's more.
Yeah. So that's but the question was, if you then work with the data, we also find that Python is faster.
Okay, but we can check that.
Yeah. I would like to see that.
But the other, I think, for me, one of the most important properties that Python has compared to IDEA is that you can run Python in parallel.
And you can run IDL in parallel.
Yes.
You don't even have to do anything for that. If you have the right number.
They pay you now.
We know IDL is good.
I will show you. That
The question is,
that's very simple to link Python with
But
MPI.
you can't use MPI. It's just shared memory. Yeah.
IDL can run in parallel on shared memory machine easily. Okay, that's true. But with Python, you can use MPI command directly in the Python program, and that's beautiful. I will show you example. That's incredible with good scalability. So the main Python website is this one, python.org. You will find everything, every information, downloading the code, and etc. But also, there is another website, the SciPy, and I will briefly speak about the SciPy. The problem with Python in the past is that there are a lot of modules. For example, if I want to deal with arrays, there are numerase module, numeric module, and all of these modules are quite similar. But the problem there is no merging of the module together. And actually, they try to do that in the SciPy community. SciPy is something like a merging of a lot of number of different Python modules in one library, which is SciPy. And actually, the guy which is the vice president of SciPy is the guy who created NumPy. NumPy, which is a very good scientific module for computing under Python. So actually, SciPy is growing because it's trying to generate only one scientific library for Python, which is good. As I said, for IDL, you have everything in one software. Under Python, that's not still the case. So how to install Python? So first, you need a good version of Python. I think now you should install 2.5, which is a minimum. So that's my time.
You mentioned that Python was modular,
Yeah.
right? And you made it sound that that is a good thing.
Yeah, it's actually a good thing.
Now you said that is bad,
No, that's good for you.
to have
For you, if you code,
SciPy,
if you code something, that's good to have for example, if you have a project under Python, it's good to have modules. You import your module, I import my module, that's okay. But for the main program, for Python, that's not very good to have a module for plotting, a module for manipulating arrays, and so on. So that's what I say. The engine must be unified. But after you or me, we have our own module compared for different physics, for example, and that's good to have modular aspects. Okay?
If I can make a comment that there are still modules within this CFIT or SciPy,
Yeah.
SciPy,
Yes,
there
SciPy.
are still modules.
Actually, as I will show, as I show here, you need Python, you need NumPy. NumPy is a scientific computing package. You need SciPy, but actually, as I said, NumPy is moving into SciPy. So maybe like next year, for example, you just need Python and SciPy. And if you want to plot, you need Matplotlib, 2D plotting. You see? So if I run a program, I want to plot on the Python from array, I have to load NumPy, I have to load maybe SciPy if I want to do something on the arrays, and then I have to load Matplotlib. So that's quite, compared to IDL, that's not so unified. And optionally, you can install Python, which is a shell for Python. It's very useful for interactive session as IDL. BaseMap, which is a module for doing map projection on a sphere or orthographic projection and so on. Very useful for star-in-a-box simulation. PyPar, so that's a parallel Python module, which is an interface with MPI libraries. That's a very good thing. PyQ, to be said, PyQ is to do Q-like widget very easily under Python. I will show you an example how to do a widget under Python, no problem. And MyAV is for 3D plotting. And actually there are MyAV and MyAV2. And MyAV2 is a new generation of MyAV. MyAV2 and SciPy in fact, does not belong. They do not belong to the Enzo. Enzo is a private company. And Enzo, in fact, manage the development of SciPy and MyAV under GPL. But at the basis is private company. Enzo.com. So Python.org is for downloading the different version. And you should see the history of Python since 1999. So, one question is from sources or binary packages? Of course, for all platforms, everything can be compiled from sources. It's under GPL, you check the sources and you compile for your own stuff. But of course, that's quite heavy. So for Linux, Windows, and Mac, at least to my knowledge, there are binaries which are provided. Under Linux, you can install that binary using U, apt-get, U for Fedora-based distribution, apt-get, and I think dpkg for Debian distribution. On Mac, you can use Think, which is the equivalent of Yum or apt-get or dpkg. Macport, which is almost the same than Think, two concurrent website organization, or directly from DMG. DMG, it's something like the equivalent of the RPM Linux package for Mac. So here I put an array of my of one of two machines I have. A Linux one running Fedora Core 7 and my MacBook running Tiger. So Python, NumPy, SciPy, Matplotlib, ePython. So you see Python is 2.5 something, NumPy is 1.0 something, SciPy is 0607, Matplotlib 090, and ePython 0.8.
Where did you become? Did you compile that from source? Or did you
No, from binary package. I will show you where. From on my Linux box, I install everything from the Fedora website. It's included in Fedora 7. Okay? So Python 2.5, 12. And in fact now you have Python installed by default because a lot of administration tools are written in Python. So if you want to, for example, add a printer, you must install Python. So the basic installation in November 2007 for me. So NumPy, SciPy, Matplotlib, and iPython. So by default, this package has been installed. And then to do projection on a sphere in April, I install BaseMap. So package, and to do widget, I install VTK Python, and VTK Python install this package. So on a Linux box, that's very easy. On a Mac, that's quite different. From the python.org website, there is a link to the pythonmac.org website, and there are DMG package, but you see that there are still numeric, which are old library. Now we should install Python, Matplotlib, and NumPy, and that's enough. It's not necessary to install the DMG package. And as you see, there are no basemap package, just Matplotlib. It means that it's not, there are some basis package, but not the whole thing. So I prefer to use this one, which is a SciPy Super Pack, because in this pack and in the SciPy superpack, it's a DMG binary package. Everything is installed in the package. So you have matplotlib, IPython, NumPy, and SciPy in only one package. So you install this DMG file and everything is okay. And the other thing is that it installs the G4tran compiler format at the same time. So that's a good address for Mac people. So on the MacBook, using the SciPy superpack installation, I have around 12 packages, something like that. So that's also the same than on my Linux box, except that I don't have phase map on my machine. And the PyCar module that I show you for running in parallel, it must be installed by sources, from sources. It's not a binary package. So now in the Pencil code, Python is a Pencil code repository. In fact, Jeff installed the first Python repository in the fall of 2007. And I would like Jeff to be there, but
unfortunately he couldn't make it. I thought that he might join in on Skype today, but I didn't hear anything from him. That's a conference at the same time.
Yeah, that's a bad thing.
Yeah, too bad.
So Jeff installed the first Python repository in NumPy. So that's the commit log, and then you say, oh, added Python script for reading pencil code data. So he has no time to make more oriented object pencil code package. I will discuss about that later. And he say, nota bene, you can't force the byte ordering is inverse compared to Fortran and IBM. I will come back on this point. He added also NL to Python, so that's useful to starting from param.nl, param2.nl to Python to get the variable or the parameter of the run. And I hope that our model will be useful for people. So you see that's quite new for 2007. So actually, there are 3 directories in the code. The reading stuff to read variable, var file, read, etc. And the math stuff to compute various differential operator or to make vector multiplication manipulation. So that actually is a 3 directory in the pencil code repository.
With naming, did you follow any naming conventions?
We have to change. Yes, I will come back in my
But I
conclusion.
know with IDEO, with the IDEO directory, it is chaotic, so I think simple Python just start.
It's
You really have some naming
Yes.
conventions.
Actually, it's NumPy, pencil, something. So I think we can remove that and we just have Python. That's okay.
Yeah.
But maybe we should ask Jeff also is okay for that. As if we do that, we love the compatibility with form of path. For example, if Jeff has some path in his logging file or something like that, pointing to NumPy, pencil, something, it's okay.
But you know, with SVN, we can do symbolically.
Yes, but we can do symbolic something, and that maybe the best way to do that is to discuss with Jeff, with people using Python. Okay, now we will use pencil code / Python, something like that. It will be okay. And then when we source the source me.csh, so now forgot the F90, it's just pencil code source me with the SVN moving. We initialize, in fact, this variable, Python 5. If this variable already exists, we had simply pencil on NumPy, and if this variable does not exist, we just put pencil on NumPy. And this variable is very important under Python because when we import something, we import a module. Python will search the modules directly from the Python value. Okay? So suppose that my variable is Python path pencil on NumPy. I'm starting in Python. In Python, I import the pencil directory, import pencil as PC, okay, and I'm doing PC dot. I will show you immediately what does it mean. So I'm under Python.
Make it bigger. Can you make it bigger? Thing?
Ah, yes. Yes, it's, yes, if you want. On my Mac, okay. Up. Edge. Okay. So I launch ipito. Okay. And I import the pencil directory. And then PC tab, you get the completion, okay? And you see what you can do now when you load all the pencil code modules. So what you can do, you can read dimension, read the grid, read the index. That's what we code with Thomas, the index. Param, slashes, bar file, average files, and also the mathematic function curl, curl2, div, dot, dot2, grab, etc. So that's very important to initialize the pencil modules before starting Python. So that's one point. If we look this file in fact is read when we load the pencil module. Import pencil. This file is read by Python. And in this file there is from pencil file.ts import everything. So in this file, ts.file, there's a lot of subroutines, and all of the subroutines are loaded when we import the pencil subdirectory. Okay?
Why the underscore?
Hmm?
Why the underscores?
That's Python. Yes, you have some kind of strange character. It's double score, double underscore, ID double underscore. It's the same with version. For example, you want a version of a module, you load the module and you print underscore underscore version underscore underscore. There are lots of variables like that.
Okay. But it's part of the convention. It's not necessary to use convention.
Yes, it's convention, but we have to respect, I think, the convention.
Suppose when you say import pencil, then it goes to that directory and reads this init.py, and then it knows what to do.
What?
When you said
Yeah.
import
Yes.
pencil as
Yes, you are. No, you don't. You are not in this directory. You are everywhere on your machine, except that you have the Python path, which is linked to pencil on NumPy.
But I don't understand, how does it know what kind of modules are inside the pencil structure?
Because you have already initialized this variable. So this variable is pencil underscore on NumPy, and when I import pencil, the Python program search pencil there.
Okay.
Okay?
Yeah.
And in this directory there is a init.py file,
Yeah.
and initialize, you load everything from there.
Alright.
Okay? And then, for example, I import pencil as PC, and then I'm in the for run pc.ret underscore ts. I plot the time series. Okay, so for example, underscore ts. Boom. I have the time series.
So what did it plot now? Why did it choose?
This one is a very short run, just for. I can do that if you want on a run which is more longer. Okay, tac, import, basic. Okay.
So why is it plotting those two? You must have written far more things into the time series.
Oh, Actually, it's written like that. But I will show you.
That's the default, yeah?
Yeah.
That's the default thing. And how do you plot other things?
Good question. Thank you. So now, the important point in Python, one of the important points, that we have classes in Python. So we can take advantage of that. Instead of reading directly pc._read_ts, we first say, okay, A equal to pc read_ts, and A become an object. Okay, and if we look at the properties of this object, what is called the attributes, we get all variables. See, A equal to pc read ts. Okay, and now A dot. You see, that's what we can do with this object. This object has a plot subroutine, but also all of the fields that are enclosed in time series. So now we load, for example, matplotlib, but normally everything is automatic, and it's just to show you, because normally we load all modules by default. Import matplotlib, for example, as p plot, and I plot, for example, a.t a.urms. Except that I already load matplotlib. Okay? You see, I use the attribute of the object, which is time, and urms. Okay? If, for example, I want to plot, I don't know which one, dtenu, which is an attribute of the object, I just plot plot directly a.t nu. But maybe I can close the window because you see. And that maybe I will show you, I will say in conclusion that actually is not written like that in the pencil code directory. So that's the example. Huh? So I plot a.t, for example, SSM, which is the mean entropy in the box, and I get this plot. So we plot the other variables as in time series, which are embedded in the object A. Another example using the read var subroutine. I read the var file a equal pc read var. Okay, so A become an object. What are the attributes of this object? We get the grid property, dx, dy, dz. We get the field, the f array, but also we get each field separately. That's because we wrote an index. And this index is able to separate from the f array the various fields which are enclosed in the f array. And then we get also the velocity field there and the grid, x, y, z. And then we can directly plot, for example, the entropy at the top of the domain. So that's 32 cube run of convection.
Boris,
Yeah.
can you load magic with this Python PC array?
What do you want?
Yeah, the magic.
Yeah. You want to check that?
Yeah.
Yes, PC read var. Okay. So, for example, like that.
Yes.
Boom.
Yeah.
But I can also say, so I have two processors. So what attributes I have now? I have all of that. So you can just you type a dot and with a tab, okay, you can see.
Well, I guess the question was, all the things that are implemented now in PC,
Yes.
is it also in the Python script?
Yes.
Because in the Python script, so in the PC read var, you could say you want to read the graph UU,
Exactly. Everything we began to transfer with comma the magic variable, for example. For example, if I want quiet equal true, that's okay. If I want tremor equal true, that's okay. Okay? And then now we have all of these attributes, and I want, for example, in show, I will plot the entropy at the top of the domain. Okay? So in Python, that's very useful. -1 means the last point. Okay?
So then what do you do there now if you want the temperature?
The temperature?
Yes.
No problem. You can code. So you can in using the magic.
Yeah, exactly. Yeah.
I'm not sure, but maybe you can.
That was my question.
I hope that it's okay. So normally it should be
Yeah,
TT,
TT.
something like that. Okay. Yes, we could.
No,
So you see, and you see this crazy command. This crazy command. This one. What does it mean? As I said, the ordering in Python is the inverse of the Fortran one or the ideal one. We should here be careful. In Python, the arrays are ordered like that: nvar, mz, my, my, mx. That's completely reversed from Fortran and IDL. Okay. So if I want to plot the entropy at the top of the domain, as here, okay, I must the first dimension is the z dimension, the second one is y, and the last is x. And you see this crazy command? You just take -1, saying that it's the last point of the z grid, and other dimension is the dot dot dot. And Python understands that finally this array is a two-dimensional array, and you take it's like TVSCM in IDL. Here it's image show.
Except that this one comes with X's on actually.
Yeah.
Right, the TDSCL can't do that. Right?
Exactly. So, now another example of post-processing with Python. So 3D plots with MayaV, which is very easy to do. It's not quite difficult. So it's, for example, two slides for star-in-the-box simulation in a plane and a perpendicular plane. The velocity field, the magnetic field in a fully convective dwarf simulation, which is quite experimental, because we do not control the whole thing on the plot. And base map is map projection. So when we run star-in-the-box simulation, we interpolate the point on any surface, that we give the radius of the surface, and we can project the field on this surface using a base map. In this case, it's simply something like a spherical harmonic, but we can do a better job star-in-the-box. So MayaV for 3D plottings, as I said in my introduction, it ends up software under GPL, and actually it's called MayaV2. And it's growing very fast. So be careful, the ordering is... so I will show you an example of that to confirm that the ordering is...
So how does this image show?
In show,
Does it have as on the x-axis, the y-axis then, everything transposed?
Yes.
yes, you can do, yeah.
That's transposed.
Yeah. So for example, in this code, in this run, I put 16 points on x, 32 on y, and 64 on z. Okay? And if I load the var file, any var file, so a equal root var something, and if I ask the shape, yes. You see? So I have to trim all. I remove the ghost point, okay? And then we first get Z, Y, X. So be careful with that, because when you start with Python, you forget this rule and you get completely wrong thing. And you don't understand why, because sometimes we have the same number of points in each dimension, each direction, for example, 128 cubes, something like that. And we plot, and it look fine. Okay, well, and when we begin to try and compute some equilibrium profile, something like that, things are completely wrong. And oh, what's happened? And then we begin to search in the pencil code, what's the problem here? And it's not in the pencil code, it's the byte ordering of Python.
You could also have written up a quick letter for ANA.
Yeah.
Brand new result.
Would it make sense to transpose this
Hmm?
when reading? Would it make sense to make sure that you get the same order? Because normally you would really want to have X first, Y, then...
I thought about that. I said, why we don't put in a regular subroutine the transpose, for example, we transpose the array.
There might even be routines that read it transpose, so you might not, you might even get around having to play with the data.
If we do that, we break the Python convention. I think it's not a good idea.
No, not at all. If we do that, we bring the data into what corresponds more directly to the Python convention.
That's not true, because this one is better, I think, than IDA. Because when you plot, for example, in a 2D plane, MZ, MY, okay? MZ corresponds to the row, and MY corresponds to the column, which is normal. You see? In the plane XZ, okay, X corresponds to a column, and Z corresponds to a row, okay? And then if your array is organized like that, it's more natural, I think.
There's lots of discussions of that sort about whether C index ordering or C indexing or Fortran indexing is better, and I always found this very, elusive. I don't think there's a clear winner there. Sometimes it is somewhat easier to work with matrices because you index them the same way as you do in mathematics, but that's about it. But I think none of this is conclusive. I'm just thinking that it is natural. What is natural? Well, it is a mere superficial convention to put rows in as one index and columns as the other, not the other way around. I think it is a much deeper convention that is more dangerous to find, to expect X before Y and to expect Z last. So in that respect, I think it would be more natural to change the order. If the pencil code was written in C, we would still have X as the first for the first index, Y for the second, and Z for the third, and not the other way around.
Really?
Because that
wouldn't we want to have a pencil the fastest? Fastest. What's the word?
fastest direction.
Fastest dimension.
Okay, maybe we would not have it, but then that would be due to limitations from the way memory is accessed and so on and so forth. It would not really be desirable.
No, but
In a sense, we're lucky with the Fortran convention because that also makes it more straightforward to write efficient code here.
But the reason you store it like this is because in Python, the last index is the one that varies first.
I suppose that's for that. So normally, in this case, the pencil code is not compatible with the...
But to some extent, then it's only about efficiency.
Yes, the cache. Well, but actually, the cache
you store your
memory,
data.
the cache access is no more a problem, I think, no.
That may be the reason why it reads data faster than IDL.
No, IDL uses the Fortran convention.
IDL uses the
But
Fortran.
IDL is compiled in C, you see.
Fortran compilers are compiled in C as well. I mean, that's true.
I think it's that for historical reasons, this ordering that.
I'm not sure whether efficiency is still such an issue at the Python level, but okay, then maybe, I mean, we don't have pencils at the Python level either. This might, that's the first argument I hear for maybe sticking with this order, that might make sense. But it might also just not apply. But other than that, yes, I agree. In C, we probably would, for technical reasons, and also it would bite us over and over again, we would probably write indices like this, but it's not really desirable. It's desirable to have X and then Y and then Z.
But I don't understand, in Python, if I want to define an array outside the testicle of size 7,5,
Yeah.
am I not, then I want to stop with that convention, or does it matter then?
No. Well, I'm claiming that then you would not do it this way around.
I
And there's no
pretend that the first direction was X and the second was Y, even though Python internally would think it was the other way around.
You can trick yourself as much as you like with that. If you have a three-dimensional array to declare in NumPy, and if you look at the tutorials, I'm practically certain that you will have a hard time finding a tutorial where they will put the X index last and the Z index first, because that's just unnatural.
So what you're saying is that I can work with Python with where I say my head is X and then Y and then Z, and then I will get no problems, even though Python internally will believe it's the other way around.
No, if you write a binary file in the Fortran, X, Y.
Python is not internally thinking anything. That's like my mother's argument that it can't be that the image we see is upside down on your retina because then the brain has to turn this around or something. It's not like that. It's just an image of what we see, and there is an interface for getting the optical rays from there into my brain. And what happens in between, I don't care about.
Sometimes you have matrix operations that have a certain way of multiplying columns by rows.
It's all about efficiency.
And this was depend on whether you were thinking that
those matrix operations, it would be very strange if those matrix operations would assume that weird ordering of a matrix.
But they must surely, if that's the way Python does it.
Can you explain then? I mean, two questions. And first of all,
I mean, it's all about whether if your array starts with 1, 1, what is the next element in memory? Is it 2, 1 or is it 1, 2? And so in Fortran it's 2, 1. Yeah? So it's stored 1, 1, 2, 1, 3, 1, and then the next, right? So if you map that though in C or in Python, it wants to have, it starts with 1, 1, and then the next element is 1, 2. So if you want to take your binary representation of your array from Fortran, which is written to disk, and you want to read it in one go, you have to swap the order of the images.
This I understand.
And so, but I mean, whatever you do with it afterwards doesn't matter. The only thing is that if you vary the index, so in Fortran, if you vary the first index, if you say I want like a colon, comma 5, it picks up this whole row in one go because it doesn't need to jump. They're all adjacent, and the same is true here. But then, it's the other way around.
Yeah, and you have to be careful. You have to be careful with loops. And in Fortran, you would loop over C first, but in this case, you would loop over X first.
Yeah. So two questions. If you say show image now, yeah, or what was it called? Show image, yeah.
Initial, yeah.
Initial.
Yeah.
And you have something which has a dimension, it would then have the dimension my and x.
Yeah.
Does it plot it in this way?
Yes.
Yeah. But then we
and you see
should
that
stop something, but then everything is okay.
And Y is the row. And X is the column.
Yeah.
For me, that's natural.
So then we should have, then this is of course okay. And the other thing is, if you have an A, which in ideal you would write A times B, for example.
Yeah.
Would that be the regular matrix multiplication? That is I, B, J, K.
Mm-hmm.
The answer is yes, yeah?
Yes, and you have to be careful, yeah. I don't.
But I mean, obviously, if this is the case, we have to stick to the internal I think I mentioned we have.
Well, there are switches to intro, I think. Where you can
But that's a natural one then, I guess.
Yeah.
But for this problem, wouldn't it be interesting to have to access to this by a dictionary rather than the list of arguments, just to say X is that, Y is that, so that the order is not important, just to have a higher level access. You understand what I mean?
No, no.
Just to say, when you have a dictionary, you say X dot is that, Y dot is that, and so that the order is not important. Just to have a higher access of this object, and then just rather than put the arguments in the right order, and so that the user just don't care what order it is. It will be just a little more heavy when you write it, but then I don't know.
But I mean, that works if X, Y, and Z are coordinates, which in this case are not even part of the data object. But if you just look at this image show command, it just gets an array, and that array has a certain order. So in that case, you don't get around this.
But at least, the components can go into a dictionary. I mean, if you have n bar, different components can go into dictionary, it becomes easier to apply.
Well, that might already be the case.
A dot UU and A dot BB.
Yes.
I think you already have that, right?
What?
How do you get to SS, which you were plotting from when reading the data, you just get A.SS and so on.
Yeah, sure.
Yeah, so that's already the case.
Yeah.
You see, if I read the bar, okay, and A is the object. In this object, you have all of these attributes for the moment, but you can have more attributes if you want. Okay, and that with Thomas we wrote this one, A dot, because before just write this one, A dot F. You see, so the F array of the pencil code, and Thomas wrote an index which takes the index number if index.profile, and it transforms that in Python and made the connection between the F index and the field.
So this is not using twice as much memory? It's not?
No, we made some test of that. Because in fact it's not a physical array, it's simply a mapping on this array.
So UU is a mapping, is a vector mapping, and UAQY you see just scalar. UU and
I want to call that.
So you now both have UU and
Actually, the velocity and magnetic field. Passive scalar is very simple. I think it will work with passive scalar because the index is a library, Python library. I think it will be fine. We can check it. So be careful with the ordering. So now the question is migrating from IDL to Python. So a lot of people thought about that before us. Huh? So there are some useful web guides. For example, the Space Telescope Institute has a good web page showing the IDL command and the Python equivalent. So that's useful when you start under Python. Another good web page is this one. I will give you the link later. IDL, Python, the description. So that's also useful. You see, for example, IDLDE, Python Python, A equal 1, B equal 1, A equal 1, comma, B equal 1, etc. It's very useful. And for lazy guy, it exists E2Py converter. I never use this. I'm lazy, but I don't want to use this one because I think it's something like a black box. And so it's a Google project. I discovered at the same time that Google has some kind of SourceForge website when you can deposit your project, your open source project, which is called code.google.com. Yeah. And this guy put his project on this web page, and in fact it's it claims that you can convert directly IDF script to Python script.
So you write it in...
I never tried. But
I think it's more like you have it already, and you want to use it in Python. And then you would use that script first, and then you would check it.
Yeah.
Then you would go through to see that
So,
it didn't
do
work.
you know, does it use matplotlib?
No.
Cypher? Well, a lot of the IDL commands are visualization commands, which are not intrinsic to Python, right? You
Sure.
have to choose some module for visualization.
Yes.
So do you know what this I chooses?
I don't know. I don't know.
You mean
I don't know how it works.
Command or service command.
Yeah.
But I will show you another example of interface between Qt, and Python, which work very well. So some tricks when using Python from in the air trick. First, when you launch Python, this file is read, and in this file is a configuration file for Python. And in this file we can put some good information which simplify life later. For example, we can load modules by default. So for example, if I put in Python RC import all pencil, I don't need to import pencil as PC every time. See? I launch Python and the pencil modules are loaded automatically. That's good. And then I can use directly readvar instead of using pc.readvar. Okay? But the good point that it's loaded automatically. Import just what you need, because otherwise, when we start the Python script, it can take some time to import everything. For example, if I want to plot something, I can import the matplotlib modules. But if I just want to take, for example, the square root of an array, for example, I need the square root function, which belongs to the NumPy module, and I just import from NumPy, import the square root function. I will not import all the NumPy module, you see? Because in the pencil, actually, in the pencil tree, I think there are some work to do, because we load actually a lot of modules which are clearly not needed. Okay. So import just what you need. Launch Python with -ilab option to call directly the plotting function. You see, plot, contour, show, etc. That's useful. Accelerate the reading of var file, pencil var file, by passing argument. Example. Some example of that. So for example, I want to read, I don't know how many var file I have there. I have 300 var file, okay? And so I can show you, for example, one Python script. So I import pencil as PC. From pencil setup, I import setup. I will speak about that later. And I import the Scilab module for plotting at the end. So you see here, so first in Python, you have indexation. So when you begin a loop, you index below the loop. And everything which is indexed belongs to the loop. Okay? And then to stop the loop, you have to come back at the first position. You see? So that's everything which is indexed here belongs to the loop. Okay? So I want to read from the first var file to the last one. I want to read every var file, and I want to plot the entropy at the top of the box. So first, what can I do? I can read the var file by just putting the flag for the 2D run, quiet equal true, trimmer equal true. Okay? So I do that. And you will see that it's quite slow if I do that. So, yes. I can copy, for example, this one in Toto or TT. I can just do that. No plot, nothing. Up. So I read all the var file. Okay, 100 var file. So, you see? The var file are read. Pop. It's quite slow. So now I pass the option of the run. I pass the parameter, the dimension, the index of the run. Okay. It's the same than with read var IDL subroutine. In read var IDL, we can accelerate the reading by passing param, grid, dimension, and so on. Okay, and we call it the same in Python. That if you want to read rapidly var file, you have to pass the setup parameter. Okay, that's the
what?
You see here the setup parameter param, dimension, index. Otherwise, these parameters are read every time, every call to var. Okay, and you see one of the weaknesses of the actual Python script is that it's not correct to do that. In fact, the best way to do that is to inherit the setup class, to define a class corresponding to the setup of the run, and var file normally this one read var will inherit the setup from the setup class. I will show you, that's what the discussion that we can have later on object-oriented script. That's what Jeff told in this commit. So now you accelerate by passing the parameter of the run. You can also accelerate the graphics by using an under. This thing is very important also. Example. So I read the var file, and I plot using the basic way. The basic way is simply to say, okay, I use imshow. So every time, for every var file, I plot using imshow. Imshow. So show you. You see, pop. That's the entropy of the top of the domain, and then you see the refresh, pop. So every time, what's happened here, every time the figure is rebuilt from scratch. Okay, so the window appears every time. I want to accelerate that, no problem, because in Python it exists what is called an under. An under is this one. You know the term under. Acceleration using an under. And that's wonderful. For the first, when I read the first var file, I put an under. It means that image equals this one. And after that, I don't plot the whole thing. I just plot what is changing in the figure. Okay? Using this command, set data.
That means that the coordinate system is already there. Is that it?
See?
It means it doesn't have to open the window again and define the
Yes,
coordinate system.
exactly. You don't have to open the window at each time to plot the basic coordinate, etc. You just refresh what is changing there, and it accelerates so much.
I mean, there's a similar thing with IDEO with slash no array, no slash overflow. But that has a tendency, if you have text, it actually just keeps what's there and writes on top, so if another text just comes on top of that.
It's something like overplotting, yeah. Yeah, I agree, yeah.
Or maybe
Except that overplotting, you can overplot in a small region. There, in this case, you overplot exactly the same array,
Yeah.
the whole figure. So you see, you accelerate the graphics.
Yeah, but I think his question was whether you raise anything, and maybe I think you do. So I would maybe, I mean, an idea, the other thing is to do it with an internal reader.
You put it in a Z buffer?
Yes, sure. It will accelerate so fast. Also. But if you put in the Z buffer, you don't show the results on the screen.
No, but unless you put it back in again.
That's true. It's accelerate for doing movie, for example. That's very useful. The Z buffer. So you put a handle to accelerate the graphics. Okay. And last things, you must take advantage of class and object. As I show you, when you read the var file, you put all the stuff in an object, and in this object you have everything, the grid, the dimension, the field, etc. And also, in Python, you can do that. You have, for example, an array, and you want to know the shape of the array. Normally you will do shape, in parentheses, the array. But this one is lower than this one. This one, the array is already in memory, and you apply the function on the array. In this thing, you send the array to the function shape.
I can't believe that this makes a measurable speed difference.
It's faster. I read on.
How long can it take to find the shape of an array?
It's faster. You can read on the web on Python manual that this one is more rapid than this one. If you have to manipulate arrays, you manipulate arrays. I want to have the mean of the array, for example. You can do that, mean A, but you can also do A.min. And it's faster to do that. Don't ask me why. In Python, it's fine. So now, certainly the most exciting stuff for me is this one. It's parallel Python. So a guy coded a module, which is called FilePar. It's a source code project. I think we had to discuss also on source code later. And this module is exceptional. In fact, it's an interface between MPI and Python. So I will show you an example how to compute, for example, a vertical profile in parallel on a three-dimensional run. I have a three-dimensional run, and I want to compute the vertical profile of entropy and density. The run is 128 cube. Okay? So let me show you. Oh yes, of course. I lost the connection during the talk. Let me see shall. Oh. No, not Apple. This one. Oh shit. Somebody has a VNC server there. He broadcast you see. Somebody broadcast VNC server. I don't know, Apple and Smack. Somebody broadcast the VNC. Shit. Okay, I have to force. Okay, now. So, let me show you an example. Okay, I have a convection run here on my machine in Toulouse, which is 128 cube. Okay?
So you're running Python in Toulouse at the minute, yeah?
Yes, we can, yeah. So, this is the code. So, the parallel Python code. So, everything looks normal. Huh? I import Pencil as PC, I import PyLab, I import NumPy, and I import this one, PyPar. PyPar is an interface with MPI. So, for example, I want to get the number of processors that I use for my run, PyPar.sci. The root processor, my ID, PyPar rank. Okay? And then I have a loop. I read the loop.
Sorry, where does PyPar get this information from?
From MPI. You run this code by using MPI run.
But how did you tell it that you wanted to use 4 processors?
4?
How did you tell it that you wanted to use?
Because I run MPI. I show you.
MPI runs NP.
MPI run.
Directly from the vector code output, you mean?
MPI run, my MP, for example, 4 processor. Yeah. So first, how many var file I want? I want to write 32 var file. Okay? 32 var file. for this one.
Does that work with local disk?
Yeah. So it's the loop. Huh? I loop on every bar file by using PC read bar. I took the horizontal average of density and entropy each time. Okay. And after that, I will compute the mean profile. Okay. So NPI run. First, I'm running on single processor. It's possible. So it begins. We read each bar file and compute the horizontal average.
But the reading is not fast at all. The reading cannot be faster. But it's the same hard disk. They're all trying to read from the same hard disk.
Yes.
So the reading is not fast. It's just the computations that are faster.
The reading is the same. Each processor will read. So the reading, you see, we read and compute the mean, the horizontal mean. Okay. It stores the value in an array, and at the end, I compute the temporal mean of the profile. As you see, it's quite long. I get density and entropy. Okay? So maybe I can do that. So how long does it take? 39 seconds. Okay? So now, I want to run that in parallel. NPI run minus, or maybe in this window to get on two processors. And first, what you see at the beginning, say, two processors. Processor 1 at interval, processor 0 at interval. And actually, the reading is in parallel. Every processor reads its own bar file. And you see that there is two, so that's very fast, 20 seconds compared to 40 seconds, factor 2. You see? Factor 2, so the scalability is correct. So now, 4 processors.
That's on the same machine?
Yes. This machine has 8 processors. So 4 processors, and here you see 4 Python are running, 4 Python sessions. And 11. Wow. So the scalability is very good. You see? And of course you get the same results. So, and of course you can go to 8.
So these data, were they, I mean, how many proc directories do you have?
Proc directory, just one. It's
the run itself was
the directory is there.
Was not in parallel.
On 8 processor. Okay?
The run.
The run directory is there. Okay?
But how did you do this with 4 processors? That meant that only 4 processors would be
No, you must separate the run and the post-processing. The run is on 8 processors, but the post-processing, I decided to do 4 processors. It means that each processor will have, it's the reading which is parallel. Okay?
But they all read different snapshots.
Okay? I will show you the sample. So what I'm doing there, each processor has his own var file, okay? And then once the reading is done, each processor sends to the root processor the profile. Okay? Density and entropy that each processor computes itself. And the root processor receives the density and the entropy from the other processor and compute the temporal mean. Okay? And you see that very simple, huh? Par send, par receive.
You could even run that with 3 or 7.
Of course, you see here the tuple, TMP1, 9, comma, TMP2. With Python, you have tuple. Tuples means unchangeable list. Okay? Yeah. So here I send 2 arrays and I receive 2 arrays at the same time using the tuple. And you can send what you want.
Yeah, but I mean, you basically round robin distributing the individual bar files that are to read to the processor. So you could do NPI run minus NP5
and it would still do the job.
For 32, yes, maybe. For 32, yes, I think this case is possible. I think I have got this one. You can check npr1 minus np5.
But that means you are not saving memory now. You just say each process.
So 4 interval, an interval, 6 bar per processor, and maybe the last one has 5. Now you see the problem.
Well, I think
we should have a multiply. I have
but you could easily do that, right?
Yes.
So there's no direct link between the number of processes that you were running this on and the number of processes that you use for analysis.
I agree. It's completely different, the run and the post-processing. So I can use 2, 3, 4, what I want.
But Boris, if my problem was now memory, that I don't have room for a snapshot in memory, then I would like each processor to only be a partial snapshot.
That's true. In that case, this one is not for parallel memory. It's, each processor has. In that case, that's okay because you, the array on each processor, the size of the array is defined by the number of var files for this processor. So in that case, that's okay. But I agree that it can be quite more difficult if we want to play with parallelization, spatial parallelization.
But it should be possible to program.
Yes, it will be possible. Yeah. Everything will be possible because it's the same syntax than with MPI. And then at the end, you have to finalize the MPI topology using PyPar finalize. And you finish. Pretty cool, huh? Mm-hmm. So, this is a very good thing. Another example, for example, I want to compute a movie and I want to write PNG file for each var file. See? Exactly the same. I define my loop, my var loop, okay, and I doing an handle for the graphics, im equal to im show and set data, and each processor writes its own PNG file. Okay. And it can be very fast also. Example, for example, how many var file? Okay, I want to do 32 PNG files. Okay. So first, I'm doing that on a single processor. Right. He read the var file and he computes the PNG, the entropy of the top. And it's something like the Z buffer. You see, I said I don't plot the figure. Yes, I see. So how many? 11 seconds. And then I'm doing the same thing with MPI. Minus MP2, for example. And now each processor computes 16 var file per processor. Okay. Great. 7. You see? So it's very easy to compute in parallel things with PyPar. Very easy. You just have to manage the send receive stuff, but it's not very complicated. The last thing I would like to show you is using widget. And it's very easy to do widget under Python. So normally widget, one way to do widget is to use Qt. And Trolltech, which is a company who is doing Qt, wrote this beautiful software which is Qt Designer. Qt Designer allows to do widget very easily. So first, Designer. So what I want to do a widget. Okay? So that's the form. Okay? And what to do widget. So I click push button and I put a widget there. Okay? And I associate a signal to this widget. So the signal is click. What I would like to do when I click on this widget. Automatically, external window is open, and you have to fill there what you want to do when you click. So for example, I want to print hello. Okay? Yeah. So print hello. I save this form. So I save this form in my directory for on and on. Okay. Save. Yes, of course I have to specify. Okay. So I quit, and I have the Qt. This one form entry. It's the Qt script, and then I want to transform this script in Python, and there is a module which is called PUIC. I give the Qt script and I write the Python script. Okay, and it converts the Qt script in Python. And then I can run the Python script. And we get the widget in Python. Push button and hello. So you see that very simple. And the function can be modified by hand without problem, because this function is written in Python. You see? Def push button, print hello. So it's very easy to do using the designer, and it takes a lot of possibility for the widget. Button, container, database, text edit, a lot of radio button. Radio button is it's a binary button. You can have here, you click or not the button, and you can associate a value or something like that. So remember,
in an ideal too, right? So
yes, but
what are you doing with Python?
I agree with you that I already last meeting last year I showed you an example of ideal widget. So you can do an ideal widget, but it's much more complicated than that, because in ideal you don't have an editor like that, like designer. In ideal, if for example I want to code a splash button, I must code widget underscore button. I have to specify the basis, the property of the button, etc. And I have to define this one, the single angular. So in ideal you can do widget, but not so simple like that. So maybe if somebody agrees, maybe one thing will be to try to code a very simple interface for the pencil code, a simple one. For that, reading file, getting the array, the grid, the parameter, okay, and after that, plotting because as I discussed with Toby last time, the problem with widget is that we must remain simple. Otherwise, the widget can increase, the number of widgets increase, and finally you get like an airplane board. Finally, you get a lot of widgets, and you click. I did that during my PhD. I did an ideal interface, and at the end of my PhD, the interface was half of the screen. Because you want to add a property that you had a button. But I think that we can do such interface for the pencil code, but a simple one. Just reading the file and plotting the primary field, something like that. Okay? So now, let me finish. So conclusion. So I hope to convince you that Python can do a very good job in the pencil code post-processing. Actually, when you look a little bit on the web page who is using Python, you realize that a lot of world institutes are using Python. NASA, ESA, for example, the ALMA project in Chile, actually. The ALMA project, which is an radio antenna in Chile, all software is written in Python. All software. ISO labs in France, at least, large number of astrophysical labs are using Python now because IDL is too expensive. We cannot pay actually with the French budget of research. We cannot pay IDL to all people. That's not possible. And also, from a philosophical point of view, I think that Python is much nearer than IDL from the GPL framework. Python is under GPL, IDL not. So if you want to commit Python subroutine in the code, in the pencil directory, we have no problem, we can do that. Exactly. If you want to commit in the sense that we can commit also IDL, but if we commit IDL, we need IDL at the end to run the routine. If we commit Python, everybody can use the subroutine. But there are some weakness actually. The actual Python subroutine must be rewritten in a more oriented object form. And we are doing that with Thomas. For example, the class inheritance. But actually, we do not commit that because it's still. For example, I can show you an example of class inheritance. That's an important notion. So I coded this one. This one is a class. A class, a setup class. So in this class, I read the dimension of the run, the parameter, param and param2, the index, the grid, and the var file, the maximum var file. Okay. For example, I have 300 var file, var max is equal to 300. Okay. And it defines the class setup, and all of this parameter becomes now attributes of this class. Okay. And now, for tiny box simulation, I define another class. This is for spherical tiny box simulation, and you see here in parentheses setup. It means that this class inherits the setup class. So now, if I call setup there, setup underscore init, all the attributes of the setup class now belong to the spherical class. It's called class inheriting. Okay? And that's very important. And I think, for example, if I want to read a var file, normally what I could do, I could take the setup class and give the setup class to the var subroutine, the read var subroutine, such that I do not need to add all of these parameters there, like param, dimension, index, and so on. Normally, if the read var subroutine is written in an oriented object way, normally the read var subroutine should inherit the setup from the setup class. You see? And I think that's actually the weakness, one of the main weaknesses of the Python script, is that this oriented object way are not used actually in the script, not in the repository. So we can change that. Another thing, but of course that the tree must be reorganized, because NumPy, pencil something, we don't need that. We should maybe just specify, so now it's SVN, pencil code Python, if you will.
Well, I try to recall, we had this discussion before, and I try to recall what the reason for the arguments were. I think NumPy makes more sense than Python. There doesn't have to be an extra directory in between, but at least that hints at the fact that this is all about data analysis and visualization. Python could be anything.
But it doesn't. NumPy doesn't include visualization stuff itself, so that's
okay.
Yes.
Misleading.
Okay.
SciPy maybe,
But
but even that is sort of limiting because if we have these widgets and then And
Yes. I think Python is a generic name, and then
And
you
there's also-
can put Python.
There's a risk that the NumPy might not even exist.
Normally, NumPy will be merged. Normally, it's a
Then we are
place.
stuck with a NumPy directory. That's about to library doesn't even exist anymore. So.
We're not really stuck because you have SVN now.
So maybe Python, the generic name would be okay. And in Python, maybe we can have a file, math, and widget, and a lot of things like that. See? Another thing concerns the calling of Fortran or C subroutines to increase the speed. Indeed, it's possible to call a Fortran or C subroutine from Python directly, as in ideal, but it's better than in ideal because you can load directly array between a Fortran subroutine and a Python subroutine. There is a bridge between the two languages. And then, for example, you run Fortran code, and the output of the Fortran code is an array. You run a function, and the output is an array, and you can load directly the array in Python. So, and it can increase strongly the post-processing. There are some web pages where people, for example, Fourier transform, of course, Fourier transform, using the Python package, the NumPy package, for example, and hard coding, Fortran coded or C coded optimized Fourier transform. And people are running Fourier transform, compute Fourier transform in C or Fortran, and load the results directly in Python. It increases so strongly the speed of the program.
By how much? I mean, doesn't that just mean that the fast Fourier transform stuff in SciPy is bad?
In that case, it was you can have a look of
because I would think that in the end it does exactly that.
That's the point. It's
It
an
takes a
interpreted
library
language.
and calls it, and
Yeah, but it's an interpreted language, so you have to. It's above C. Okay.
but maybe I'm mistaken. But I thought SciPy or Python in some way has bindings for FFTW, for example.
Yeah.
So I'm surprised that this is not already happening with the FFT stuff that's in
No,
SciPy.
actually no. You can find some web page who are timing the FFT calculation, and finally the best timing was by calling directly a Fortran or C FFT from Python. So as you see, there are a lot of work to do, but I think it's a good idea to increase the number of Python supporting the painted code.
Very amazing. Yeah, I found it very impressive. So, thanks.
Boris, I have two questions.
Yeah.
One is that I actually tried installing this. In my Mac, I had no problem. But in a Linux cluster where I don't have the root permission, I couldn't do it. I couldn't install it in my own account. Everything was RMP based, and compiling from source was horrible. Half the libraries were there, half were not. So
Yes.
do you have any comment on that, any experience on that?
You must have if you want to install binary package, you must have the root access. Huh?
Yes, but see, sometimes happens is that the root just takes the easiest possible RPM
Yeah.
and then installs it, and then when you try to run it, you see half of it works, half of it doesn't. That's actually being a bit kind. Most of it doesn't work.
I know that it's possible with RPM to specify in another default directory.
Is it?
That's possible to do that on some package. If the package is
On
well
some package,
configured.
but with these I was seeing that the RPM package is locked and I don't have the lock to that.
I never had this problem.
The second thing is that the thing I really hate about IBM is it is very difficult, and it's not so difficult to get a nice plot on the screen. But it's extremely difficult to go from there to a nice looking PS5. So is that easy in
No,
Python?
that's so much better.
That's the one.
Yeah.
That's what I was asking.
Let me show you this one. That's very simple.
Yes.
That's very simple, for example. You want PNG file, for example.
Yes, my lad.
Yes.
Okay. That's very, very easy, because the interface is, so for example, this one. IPy, I read read var. Yes, maybe I can put that in an object. Okay, read var. And im show R, so the last point. That's what you want, okay? Yes, no, not yet. The entropy. Okay, you see there? There's the code.
Yes.
I want the PNG file. Okay. Save. And you see there SSPNG.
So how about a PS file with
You can do that when you.
vectorized fonts?
Yes, by default it's PNG, but you can save in other formats.
Yes, but can you? Is it difficult to produce?
I think it's. You can do, but you can also.
The question is basically, will this be completely rasterized, just the PS version of the PNG, because then it's not publication quality.
Yes.
So,
For example, there. File name, I specify PNG when doing the PNG file for the movie. But if you specify PS there, when you save FIG, it will automatically save in PS.
Yes, but will it be
Yes,
the
it
PS
will.
file that corresponds to
It will. This is one example.
It's line vector, line verb.
vectorized fonts?
Well, this is the usual size. And if I scale it up by a factor of 4, it doesn't look to me as if this would be.
That's vectorized. Okay.
And this is fantastic because you can actually you can have the exact same fonts as you have if you write a paper. You can use computer model for your figures.
Yes, I
You
can
can
show
write
you.
LaTeX code in the labels, and you can achieve that the fonts are exactly the same size as the text in the caption or in the paper or whatever,
Yes,
whatever you want.
So you can basically use text completely.
Yeah.
So-
Love.
For example, in this paper, for example, we wrote every figure are in.
Doctor benutzt das kannst du.
So what does Anderson?
Yeah, say. You can have also multiplot.
But this
Python.
this is PostScript font. This is embedded PostScript font.
Yes, that's PostScript font.
So if you were to zoom in 32,000 times, it would
Toby just did that, well, 400 times, and
But
fonts
you
are
don't.
crisp and perfect.
But since you can easily produce PDFs that are exactly the right size, so that you can just include them in your LaTeX document, you can, with the right font size, so whatever, column width, you can have a PDF that has exactly column width. Then you don't even need to scale. It doesn't matter whether they're vectorized or
I can
not.
do that without
But they are vectorized.
I can do that without AL also, right?
What?
Yeah, the guys.
You can, but it's a pain.
It's such a pain.
Yeah, I know, it's a pain. I have a script doing all the things for me. So.
Yeah. Idea doing PostScript line is crazy.
But why did you want to have vector fonts?
But we talked about the same thing. I want the fonts to have sharp outlines and to.
But vector fonts are not PostScript. Oh, yes, they are. Oh, that's what you mean. But okay, so.
And it might be not PostScript fonts, but TrueType fonts, so vector fonts. But
And
then I will talk about
what
something.
is it ideal called? Is their own fonts? Which are Hershey.
No, I don't want those. No. Those date back to the time of line plotters, I think.
Yeah, but if you look at the
And-
1983, people still publish things with Hershey fonts and thickness 1. Yeah.
Mm.
I find that incredible. So it always does vector fonts.
Yeah.
Even if you do, but if you do PNG, it just makes kind of a snapshot
Yes.
of the vector font. Then.
Yes.
Yeah.
So kind of a pixelized bitmap of the vector font.
No, that's much easier to do to save in any format under Python.
But you can do your labels with LaTeX.
Yeah.
Yeah.
Do you have an example of doing that?
Yes, you can encapsulate your LaTeX command. As a PS file.
You have this text to write TL
Yes, but that
program,
doesn't,
right?
that doesn't take a lot of commands.
Sorry?
That does not take a lot of commands. It doesn't take
that's
more complicated commands of take.
Yeah, that's true, yeah. But you can put
That's a very
Greek
basic
letter there, yeah.
Yes,
with,
that's true.
Yes, but I mean, all the layout stuff, the layout stuff in IDL is pretty horrible. If you try hard, you can add a fraction to a label, to an axis label, but you can't do complex things.
So if I want chi over eta, then I can write a LaTeX, write it in LaTeX,
Yes, you can write directly the LaTeX symbol.
and then it comes out with
Yes.
chi over
Yeah.
eta.
And if you
Yes,
wanna
that's impressive.
You should have stressed that.
So can you just show me? I mean, suppose, for example, you want it black. Can you just do a little demo, or let me do a demo?
Yes, yes, we have an example.
If I want to make a line, I want to plot a line, so then I want to plot omega.
Yes. So wait, I have to over the script.
No,
No, I have wrote. So wait. So, for example, vertical profile. So wait.
if you but the best thing is to not demonstrate. After time it's so you don't have to but it's a good sign of
You see? Then you see them?
What operating system is this machine running?
See,
Is this a very recent?
label.
So, Ruba, here's your thing.
That's the label, the Y label of the figure, and you see we got the LaTeX real part. Huh?
Can you enlarge it?
Yeah, well,
It's edge, I think, already. Yeah? I think it's yes, it's edge. Okay, wait, I can open this using the tech edit. So field, ADI pencil 1D test. Okay, and it's plot CK. Okay, there. Maybe I can increase the format of the. Can I increase? Oh no, not like that. I will open with the editor. Ouvrir avec. Oh shit, autre.
So, does it work for you as well?
What?
Does it work for you?
Take edit. Okay,
Okay.
good. Voilà. That's okay? What? Okay, so you see the LaTeX here. Do you see?
Yes.
Here. The Y label here, it's a LaTeX command. And when you do the postscript, this one is included in the postscript, and you LaTeX, when you LaTeX the file, no problem.
How does it know to do that?
It's magic. But you can do that with the idea using the ps flag command. The problem with that is that you must use a zero font You have to specify font equals 0.
Yeah. That's something.
And in the postscript, you have, for example, a Toto, and replace Toto by the LaTeX command. That's the problem, that you must use font equals 0 on all axes. And then that's not very good.
That means that your numbers on the axis might look pretty cramped.
Yeah, you have, for example, you use, I already used that, but you do font equals 0, and you specify, for example, the title equal to Toto. Okay? And then in LaTeX, use PS flag, Toto, and you want to replace by, I don't know, a real part of. But and then in the PostScript file, you can see Toto, but the problem is that all axes are written using font equals 0, which is a very bad font.
What about time derivative, like to add the dot, right? Because in
Backslash dot.
In dot, yes. In IDL, it's a pain to put the dot there, right?
In dot, like mass transfer. If you do that with IDL, you can either to put the dot with XY out, or you can try to go exclamation mark. But then especially with the capitalized, you go up up. So I think dot is
you can use for using LaTeX.
that should be fine, right?
Put that in the next copy.
Yeah. What's so funny that?
And the idea to put the dot with XY out.
But you can and you can also put hats, of course, with exclamation mark off. But the hat, especially for capitalized, for capital letters, the hat is kind of at the top of the character, still touching the character. It's completely ridiculous.
It is also wrong if you have italics.
Yeah, then they stay left and the italic is wrong, right?
So you first insert a subscript size space, and then space with the hat, and then you go back, and then you put the italic back there. Now all this knowledge is going to be completely useless. I've spent decades trying to get the most out of IDL output, and now you're showing us this.
You lose your power.
I guess one thing I'm worried about, maybe I'm just conservative, I think the notation, I think that the language looks tricky to me when I read it. I think at least IDL is very straightforward.
Well, the first time I saw it,
But Python is actually feels like a proper programming language to me, whereas IDL.
It's a hacking language, I know.
It's a hack. It's just a strange blend of 5 different languages from the 70s.
Yes, an idea belongs to Kodak now. Yes, Kodak company. Yes, RSI is Kodak.
But it belongs now to ITT.
Huh? It's Kodak. IDL is Kodak. Huh?
ITT?
But is it true that they make most of their money on medical research?
I think so.
And that's why they can take some.
Kodak RSC, you see?
That's why you don't care about licenses.
RSC, Kodak bought RSI some years ago. And in fact, idea is to make money. Clearly. The philosophy is to make money.
Well, you can't blame them for that, but the fact that they take so much money and then they don't change the things that we are annoyed by for a long time now, that's something you can't blame them.
There's this annoying thing with the grabbing of the command line, which I have faced ever since I started using IDL when I was at university. And there's been like 7 different versions of IDL since then, and they haven't fixed them. That's not that when the line becomes longer than 80 characters and wraps around, you cannot go back to the arrows.
But these medical guys don't use the command line, you know?
So I guess there's even some kind of development environment probably.
Use ITL?
No, I think that's even.
Thank you again.